Okay everyone, so I'm going to be doing a, probably 30 to 40 minute tutorial over the mini lessons that we went over last week rather quickly. There were some that were out last week. There were others that may have been present but weren't paying attention to anything. So this video will serve to prepare you guys for tomorrow's quiz over the mini lessons. So here are the topics we're going to cover that basically in the same order that we approached them in class through the PowerPoint. Do remember you have a study guide on this. Everything on that study guide needs to be complete. It needs to be intentional. I encourage you to fill out parts of that study guide that you may not have filled out during this video, okay? The beauty of this is you can pause it if I begin to talk too fast and rewind it and go back over something you maybe misunderstood, okay? So, I am going to be looking down a little bit over here because I've got copies of questions that I'm going to potentially put on your quiz, and I need to make sure you guys can handle those. So every now and again, I will be reminding myself by looking over there. So if you're wondering what I'm looking at, it's over here. All right, so acids and bases, what do you need to know? You need to know that acids and bases have lots of things that make them different, but then there are some commonalities, some characteristics that they share, okay? So in terms of like a Venn diagram, okay, let's basically say here's my acids, and then here's my bases, and then this is kind of tiny, so I might be going in and out of the both section, but you know what we're looking at here. All right, first of all, let's talk about their pH level. Anything that is below 7 is an acid in terms of pH. If it's above 7, it is a base, all right? Bases are also known as being alkaline. You might also hear them called that, okay? Now, acids in terms of taste are sour, bases are bitter. Acids are found in a lot of food and beverage items. Most things that we consume tend to be acidic, all right? That should, I don't know, so averages. Anyway, beverages. All right, bases are most cleaning supplies. We're talking about Windex, we're talking about Clorox, bleach. Yep, that's bleach, Victor. Thank you, honey. Any type of soaps and detergents, they're over there, okay? Now, acids and bases also you can test solutions to see if they're acidic or basic, and there's two different indicators that you have to know about. One is litmus paper, which is a little strip of paper, and it's color change that occurs whenever you dip them in an acid or base. And then there's phenolphthalein, which is this clear, colorless chemical that can or may not change colors in the presence of an acid or a base. Yes, Victor?
What if it is 7? Like,
well, if it's 7, then it's water. 7 has a neutral pH. So anything below 7 is an acid. Everything above 7 is a base. Water's like the perfect chemical. All right. Now, so back to the litmus paper. Litmus turns red in the presence of an acid, and it turns blue in the presence of a base. Okay. Now, phenolphthalein, which is that really long chemical name that you guys saw in the PowerPoint slides, and but anyway, phenolphthalein is clear and colorless, and phenolphthalein will remain colorless if you drop it into an acid. However, phenolphthalein, when you place it in a base, will turn bright pink in color, okay? So those are the indicators that you need to know about, all right? Now, other things that that you need to be aware of is that acids have a special naming system and bases do not, all right? So I'm going to go out of this bubble for a second to kind of briefly break down the naming system of acids, okay? So you've essentially got binary acids, you've got ternary acids, and then you've got, which is ternary is a metal plus a polyatomic ion, okay? And then this is going to be a metal and just an individual non-metal, okay? And then you've got, this may have showed up on your study guide. The other one is called a carboxylic acid, okay? You don't have to be able to spell that, but a carboxylic acid is characterized by having a COOH on the end. See, acids typically have the metal that we're talking about. It's really not a metal. It's actually a hydrogen acting like a metal because it's actually going to dissociate. So do know that when you've got hydrogen and a non-metal, hydrogen with a polyatomic behind it, that is characteristic, very, very common for an acid, okay? So But you may see a carboxylic acid, which contains a carboxyl group at the end and does not have a hydrogen at the beginning. Okay, so an example of a binary acid would be hydrochloric acid. Okay, and an example of a ternary acid would be like sulfuric acid. Now notice this is hydrochloric. I actually mention the hydrogen in its name if it's binary, but over here I don't say that. I don't say hydrosulfuric, I just say sulfuric acid. Okay, this right here is sulfurous. This is sulfurous acid, this is sulfuric acid, okay? Now the suffix changes based on the oxygen count. If it's going to be these sister polyatomic ions with less oxygens, you'd call this sulfurous acid, this is sulfuric acid. So special naming system for the acids. The bases don't. You just call it like you see it. So if you have, this would just be sodium hydroxide. This would just be calcium hydroxide, okay? Then there's ammonium, which is a special base that does not have that OH, all right? So speaking of those ions, the hydrogen ion, acids are known for releasing hydrogen ions when you dissolve it in water, and bases are known for releasing hydroxide ions. And that's why when you put them together in a neutralization reaction, an acid plus a base will give you H2O and a salt, okay? And so that's what you see. You see that those hydrogen and the hydroxide is actually what we call dissociating in water. All right, now that dissociation actually causes you to have these little charged particles in water. And so this is something, we're going to go to the shared characteristics. Acids and bases can actually conduct electricity when dissolved in water because of these oppositely charged dissociated ions. So that is what is called an electrolyte. Electrolytes are substances, chemical substances that can actually conduct and allow electricity to flow through them. All right. Now, another thing that they have in common is that they are both corrosive, meaning that if you go, the further you get away from 7, that is, the closer you get to 14 on the base side and the closer you get to 0 on the acid side in terms of pH, they both can be extremely harmful, okay? Very corrosive. They can break down other chemicals, all right? So this is your acids and bases. Do be aware of their characteristics, their commonalities, the naming system of the acids, as well as a neutralization reaction, which is just going to be neutralization reactions. It's just a special type of double displacement reaction where you've got these two ionic compounds, one's an acid, one's a base. They create a new precipitant, ionic compound, and water, okay? Now, Victor, you have a question?
Do they have to have the same amount of acid and bases, or can there like be more base?
Okay, so someone in class asked that. So Victor's basically saying, in order for this to happen, does it have to be the same level of acid and same level of base? Not necessarily. You can still create water. Now, if you use a really strong base and a really weak acid, then yes, you can still have some solution that is slightly alkaline because you used a stronger base with a weaker acid, okay? We don't have to get into that part of the chapter. That's something we would actually get into if we went into chapter 14. That's a great question, Victor.
Thanks.
All right, now, so now we're going to move on to our next, is it still rolling?
Yeah.
Okay, next thing we're going to talk about is solubility, okay? So solubility is like how easily and readily something dissolves. And we talked about 3 different things can increase solubility, the rate at which something dissolves. Adding heat, that is raising the temperature, stirring or agitating the solution, or increasing surface area. Now, something that we saw last week, and one of these was on your benchmark, is a solubility graph, okay? And so I'm just going to draw some lines up here, and I'm going to call these different chemicals, okay? This is going to be chemical A's solubility curve, chemical B's solubility curve, and chemical C, okay? And so temperature is always plotted on the x-axis, all right, in a solubility graph. 10, 20, 30, 40, 50, 60, 70. So we'll go up to 70 degrees, all right? Now, this is going to be temperature, and you can see how these lines trend as temperature increases. That'll come up in just a second. Now, the other thing that's over here is how much of your chemical, so this would be grams of chemical B, grams of chemical A or C, okay? How many grams we have per 100 milliliters. Now, you may see 100 grams of H2O because we're always sticking stuff in water and dissolving it. Like 99% of the time, you're dissolving stuff in water. Water's the solvent, and then your solute, it could be endless different types of chemicals, okay? So, and we're going to put these in tens as well. 10, 20, 30, 40, 50, 60, 70, 80 grams up here. This is 10, 20, okay? So, some questions that could be asked, that you could be asked in terms of a solubility graph. We went over this last week, but we could talk, I want to give some other variations of questions that you might see. All right, so one question might be, which chemical's solubility seems to decrease as temperature increases? So as temperature's going up, which of these chemicals' solubility seems to actually decline? And that would be C, all right? Chemical C solubility, as temperature is going up, its ability to dissolve, its saturation curve is going downward, okay? Now, I could ask you, in contrast to that question, I could say, of the three chemicals, which one seems to dissolve better or its solubility rate increase as temperature increases? And that would be chemical A. You can see that chemical A's solubility is actually increasing as we increase temperature. All right, now